Okay, everybody. So last time we did this, we looked at this string example, C++ new string class example, and after that we looked at similar classes in C++ standard library, standard template library, and we gave a few examples. And I hope you did some testing last night about what we did and the things that we can. Maybe I should. Is it visible? Can you see the slides? Yes. Attendance. So we said that our purpose in this class, in this course, is to be able to write classes like this string class. Okay, writing the string class is not okay. You don't just write a string class by itself. It uses some other classes in it. Okay, you don't write just a single class. You usually write a set of classes and they help each other. And we are going to see how this is useful in terms of writing reusable code, writing maintainable code, and writing manageable code. That's what object-oriented programming is all about. We are trying to write reusable code because writing reusable code makes our job, our later programming jobs, much easier. Once you start writing this kind of software, you will realize that your job is getting easier and easier and easier. That's the point of object-oriented programming. They say that when you use an object-oriented programming language and when you design your software using the object-oriented programming principles, your job as a programmer, as a software engineer, gets much easier. That's the difference between these languages and the other non-object-oriented programming languages. Okay, so any questions about this string class, or any questions about this other classes that I showed you yesterday? I think I showed you some containers, right? I showed you vector. Let's look at this list. List is very similar to actually vector. Yeah, I showed you this too, right? I mean, there are a few differences like push front and pop front, those kind of stuff. And it is easy to do. I mean, computationally it is easier. It takes less time to insert an element to a list. Well, it is possible, as you see, insert is available for list. Insert is also available for vector too. I mean, you can insert a value anywhere you want in a vector using this function, but that function is very expensive for vector. Okay, for insert it is very cheap. Okay, and it is all done it is all explained in the documentation. When you look at the documentation says that I can do this and this, and let me see if the documentation talks about, yeah, complexity, linear in the time of elements inserted. So this means that if you are inserting 5 elements, your cost is 5. Okay, so it is linear. But if I go to the vector, where is vector? Vector is here, and if I find a vector insert, okay, here it is. Let's look at the complexity. Yeah, linear on the number of elements inserted. So if you are inserting 5 elements, its cost is 5 plus the number of elements after position. So I need to move lots of elements after that one, right? Because you need to move lots of elements. I mean, if you have a vector of 500 elements, and if you are inserting at position 100, you need to move 400 elements a few spots further, right? So the cost is that much. So this is more expensive if the vector is large, much more expensive than the list insert. Okay, maybe this is too much for your background now. I mean, talking about the complexity of such data structures maybe is the talk of the next semester 222 class, data structures class, maybe the algorithms class. But I mean, if you are wondering what is it, I mean, as a customer, for me, what is the difference between a list and a vector? And you might say that, okay, list is cheaper for some operations and it is not cheap for some other operations. And let's look at this indexing operators. This is going too much. Okay, let's look at the index operator. Index operator for the list works like a vector. So index is available, but complexity, okay, this is, okay, sorry. This is a vector index. Let's look at the list index. It is either not available or it is very expensive. I think it is most probably not available. I don't remember. Operators, yeah. Operations, do you see index operator? No. Do you see it? No, I don't see it. And if I try to, where is my, okay, yeah, no. Well, index operator is not available for list. You cannot say A5. Why? Because indexing is, you need to start from the beginning to count the number of elements to get to the position you want. That's not possible with the, well, it is possible, but it is too expensive. You have to start from the beginning. So, I mean, if you are using list, index is out of question. Don't use list if you need indexing. If you are writing code like I wrote yesterday, don't use index. Don't use lists. Okay. So we will talk about this when we, okay, these are part of the standard template library, and there is a separate chapter in our book. There is a separate chapter in our book titled Standard Template Library. We will talk about these later. But for your homework, you are going to do this solo test. Okay. I'm sure many of you know about this. You know this game, right? Okay, solo test. You are going to do this solo test game. It's a one-person game. Yeah. You know this one, right? It's very easy to know or learn, and it takes a little bit time to master it, to understand what's going on. And this is the standard board, but I am going to ask you to change the board a little bit. And at the beginning, your program will not be smart, and we will try to get it more smart. So that's your homework, and we are going to work on this homework for 5 homeworks maybe. We keep changing the homework. First, you are going to start with C programming, because that's what you know, without writing any classes. Then we will start writing classes for this one. Then we will write classes that use our other classes, and it will go that way. And at some point, I'm going to tell you that without changing the interface of your classes, okay, change the main engine of your software, okay, and realize that this is happening, okay. If somebody changes how the list is implemented, okay, your code that uses the list would not be affected, right? Because you are seeing this interface only. Okay, you are seeing this interface only. So that's what we are going to do at some point. Okay, good. Let's go back to our original slides. And I don't know what happened to my slides from. I did lots of markings, right? Where did they go? Are they here? What is this? These are Vivo pages. Maybe they changed the yeah, maybe document information. No, What's going on? I don't know. Oh, no. Anyway, okay, I can write it again. So let's move on if there are no questions. We like printf a lot because it was simple. We know what it is doing. And we like it because it was very easy to do formatting, right? When you say, I like to, I don't want to touch this. Yeah. I like to print a float, okay, in a space of 3 characters wide, and I like just 1 decimal points after the point, and let's say this is my float. This was very easy, right? You could insert your format string between the %sign and the in this case f. Okay, so that's what we learned, and if I do this, I cannot use my hand. If I, what's going on? Well, maybe, okay. Now I know what is going on. Good. So they changed the interface a little bit. Can we do the same thing in C++? When we say, okay, out the price is $price, you would get this output, 78.50000, and it doesn't look right because we don't write the dollars or Turkish liras that way, right? We only use just 1 or 2 digits after the dot. So how we are going to do that? This is how we are going to do it. Unfortunately, it is not as simple as typing a few more characters. You say that cout is an object, okay? Maybe you can see the similarities between, remember what we said when we say string s and its initial value is 1ab, then I can say cout s dot length, right? That's what I can say, right? S dot length. Okay, so I am calling a function on this variable, on this object. Again, it looks like I am calling this function set flags on the cout object with this flag iOS, okay, input output system fixed point. I want fixed point displays of my floats, and I like my point to be shown. Okay, always show the point, even if the float it contains an integer, and my precision is going to be 2. So when you do this, so you modified the cout object actually. You said that, okay, I'm setting these flags and I'm setting the precision. When you print something now using cout, it will print 2 digits. It will definitely show dot, and it is going to show a fixed notation. What is the alternative to the fixed? It is scientific notation. In that case, you would get results like 2e minus 1, right? This is the scientific notation. This is a fixed notation. So unfortunately, in C++, things are like this when you are trying to print something to the screen. But I mean, in this day of computer engineering, programming, whatever you call it, we very rarely use cout and printf because we don't have the screens like that anymore. Okay, all we have are the windows, right? So we do our stuff using the graphics interfaces and etc. So I mean, cout and cin statements are rarely used. I mean, we are going to use it a lot in our programming homeworks, of course, but I mean, this is just a introductory course, and we need a way of simple putting stuff on the screen. But if you like to format your output using cout, then these are the things that you need to set. And there is a separate chapter in our book that talks about the formatting of the output. Okay? And we are going to talk about what these mean. This is a binary value, okay, it's an integer, of course. Set flags and precision. Okay, good. Any questions? Okay, I was very surprised that nobody asked any question about. Nobody asked any questions about. Let me show you an example. Okay. Nobody asked me any questions about this part. I mean, what is this int doing here? I mean, I know that this is a list of integers, but we have never seen this in C. I mean, when you do the arrays, arrays are done with either pointers or that square brackets. What is this? This is a new notation for C++. It is called templates, and we are going to talk about them at the end of the templates. For now, if you like to use lists or vectors or stacks or queues. Did they talk about stacks and queues in C? Stacks, queues, did they? Yes. They talked about arrays, of course, and lists, linked lists, stacks, and yeah, they are all implemented in here. Okay, as you see, there is a stack, there is a set, küme in Turkish, set. So you insert elements and you ask the elements and intersection, etc. And the queue you already know, list you already know. Forward list is a one-directional list. This list is two-directional. You can go forward and backward. So both of them are linked. Forward list is just a single. Okay. Dig is something between a list and a vector. So in terms of performance. Array is something new in C++ 11, and maybe we will talk about them later. But it is easy to read this documentation. Just read it, try to see the examples. Some of them you won't understand. Try to run them, and you will see that these classes are very easy to use. Actually, it is as easy as it is as easy as driving a car. Well, I mean, they might be very complicated. They might be as complicated as a car in terms of how the car runs, the details of it, but they are very easy at least at some level. Okay, at the starting level. I mean, understanding this code is not a very difficult thing. So I have a list, I am inserting it, then I am getting them out, and it looks like it is using both vector and a list together at the same time, etc. So these examples are nice, and you can understand them yourself. Okay, error output is done with C error object. Okay, C error works like C out. So instead of saying C out some string hello, okay, you will say C error. You will say I observed an error. I am printing this to the error stream. Okay, so usually C out and C error are connected to the same thing, which is the screen, which is your console. Okay, and you can change it depending on your operating system parameters or the shell parameters or shell configuration. You may redirect your output, standard output, from screen to some file, or you may redirect your standard error stream from screen, from console to some file or some other program. Okay, good. So C error is, I mean, under what circumstances should we use C error? If you are not printing a normal message, but if you are printing an error message saying that I couldn't find the file, or this name is not available, etc. This is an error, and I am going to halt my program maybe. In that case, instead of using cout, you are going to use cerr. Okay, and cin. Okay, this cin, cout, and cerr, they are like global variables. Okay, and they are always available if you include that IO stream header. And for cin, the overloaded operators are different. For cout, okay, stream insertion operator is overloaded, cin and cout. For cerr and cout, stream insertion operator, this is insertion operator, is overloaded, but for cin, stream extraction operator is overloaded. And this overload works for all fundamental types, integers, doubles, floats, longs, etc. And it is overloaded for some of the later defined types such as string. It works for the string. And it works this way. It is very simple. You just say cin, I am going to read an integer to my variable named num. And the compiler is responsible from figuring out the type of the variable and producing code to get some value from keyboard or from standard input to this num. Okay. Again, the details of this will come later. We have a separate chapter in this book that talks about the input-output from the screen, keyboard, or from files. Okay, good. These kind of things are details of the language. They have nothing to do with the object-oriented programming philosophy. And as always, when you are doing, when you are getting some numbers, some values from the keyboard, always prompt the user for input. You ask the user enter the number of dragons, okay, and you read it. So if you don't write this line, if you don't prompt the user, the user wouldn't know that the program is expecting me to write some numbers, right? Okay, so for every cin, you should have a cout prompt. Otherwise, the user would not know what's going on. You already know this from C, because for every scanf, there should be a printf somewhere. Okay. For programming style, again, it is same as C. When you are writing your code, you should write easy to understand code. I mean, even if nobody else is going to read your code, doesn't matter, okay? Always include lots of comments, meaningful comments. And the comments are done the same way in C++. You put your comments between this slash, star, star, slash, yeah? That's how you do it. Also, we have one more way of doing it, slash, slash. Okay, slash, slash, when you start a line with slash, slash, the rest of the line is ignored by the compiler. So it is interpreted as a comment line. Okay, and this is only valid for a single line, but this can go on more than one line. And in C++, we have this. In C, we didn't have this. You might say that, well, I tried this, it works for C. It will not work for many standards of C, for many compilers of C. So don't use this notation for your C programs, okay? Even it works for your compiler, okay? Do the things right, okay? You might say that I ran the red light, nothing happened. No cop saw me. I didn't hit anybody. That doesn't mean that what you are doing is correct, okay? Don't use this notation for your C programs, okay? For your C programs, use this notation. For your C++ programs, you may use both of them. Identifier names, identifiers should be meaningful, of course, okay? Meaningful names, and we usually prefer this. Okay, if you have an identifier that has more than one word in it, okay, we capitalize the second word and the third word. That's what we do it, okay? This is, I mean, this isn't used to be that way, especially when they first designed C++ language. That's why in those days they used to do, if you have an identifier with two words, for example, pushback, remember the pushback function? It is not like this, right? They did it like push back. Since it was the standard in those days, and since they named pushback like this, we kept using it, but nowadays we are using this notation. Okay, we are using this notation. But I have to call pushback, I have to use this, of course. Okay, good. Libraries, again, we talked about this. To be able to use a library, you have to include its header during the compilation. Okay, otherwise your C++ compiler will give you error messages, not warning messages, but error messages. Okay, if you are going to use string type, you have to include string. If you are going to use vector, you have to include vector. If you are going to use cout, scene, etc., you have to use iostring. Okay, so C++ has many libraries like the math library, input-output library, string library, vector library, etc. To be able to use them, you just include them. Okay, and of course these are preprocessor directives. Question: is this a C++ keyword? Well, since I am asking it, maybe there is a trick in it. Yes?
No.
You said no, right? And I think you heard it. I heard that. Nobody else, just between three of us, nobody else heard it. Just say it louder. The answer is no. Maybe it could be yes too. I mean, we are using this, writing C++ statements. So it is a include means that when it starts with this sharp sign, okay, it means that it's a directive for the preprocessor, right? Preprocessor will take it and will handle it. After that, the compiler will process our program. So the compiler will never see this statement, this preprocessor statement. That preprocessor statement, whether it's include or define or some pragma statement, whatever we are using with the preprocessors, okay, it will not be visible to the compiler because the preprocessor changes our program. Remember the -e option for the compiler, -e. What did the -e do? Capital E. We did the example, right? What did -e do? -e.
All codes include libraries.
Say it again.
Bytes.
Say it again. What is your name, AB? Let me see your name.
Atacan. Show the all headers include.
Show all the headers. Show all the headers in our program. So when you use the -e option, capital E option, and when you compile your program, this will stop the compiler from compiling your program. It will run only the preprocessor, and the preprocessor will produce the result. So remember, I think I had 30 lines of code. After I run this -e option, I produce a new program that was maybe 3,000 lines long, right? It was 3,000 lines long. So -e runs just the preprocessor, and you just play with these options. I'm surprised that nobody tried it. Are you shy or something? Why nobody is trying this kind of stuff? Is that your plan? Just come here and sit and watch me talk and come back again? You should try all of this stuff at home. Without trying these, okay, I am just telling you stories here. It is no different than stories. It's no different than listening to some history course, okay? And you cannot test history at home, right? So all you do is just read and again. Maybe watch some other documentaries. I mean, this is a programming course. You should go home and try it, and you will realize that some of the things I am telling you are not true. If you don't realize that, okay, you are missing lots of stuff. it won't be very good for you. I mean, the beginning of the semester is the perfect time to learn this language. Okay, you need to spend lots of time testing it, and when you come back next week, and when I say, are there any questions from yesterday's lecture, and I should see maybe 10 hands raising. Okay, without doing this, I mean, it is not easy to learn this language. There are many details of it. To realize those details, you have to test it. Without testing it, you cannot learn it by looking at those slides. You have to test them, okay? And I talked about this. I talked about minus s and minus g. I showed you, but I did not tell you what that means. You should test all of that stuff yourself, okay? So libraries are available, and you need to include those libraries, and of course when you are linking your program, those libraries should be installed somewhere in your system. By the way, the C libraries are available to C++ programs. To be able to include a C header, okay, tell me a C header. Okay, in C we have math.h, right? To be able to use this math library of C instead of this one, okay, this is the math header of the C++. But I like to use, for some reason, the math header of C programming language. You put a C in front of it, C math, okay? Or if you like to use a C string, for example, remember strcat, remember strcat, catenation? To be able to use this strcat for some reason, you need to include C string header, okay? You need to include them. So all the C libraries are available. Well, many of them, very large percentage of them are available. The suggestion is that don't use them in C++, because this is a new language, and you should not try to use the techniques that you develop to write C programs in C++. If you are writing in C++, use C++ libraries. Don't use any C libraries. Okay? And now namespaces. Okay? We many times I told you that, okay, we are not going to talk about them. Let's spend maybe 5 minutes to talk about these namespaces now. Okay, the definition of namespace is just collection of name definitions. What are those names? For example, collection of classes. C in and C out are in the standard namespace, for example. String library, that vector or list library, they are all inside this standard namespace. So you collect many definitions such as these: C in, C out, string, vector, etc. You put them into the same namespace, okay, collection of names, and we call them STD for our case. Okay, so everything standard that comes with standard C++, they put them inside this standard namespace, and you don't have to use this standard namespace. Okay, standard doesn't mean that you have to use it. Standard means that it is standard, everybody knows about it. If you like to use the standard namespace and standard implementations of those strings and vectors and everything, you include this statement at the beginning of your file. Okay. After the include, you say using namespace std, and after that, anything inside the std namespace will be available for you to use directly. You would say I am C in, C and C out. The compiler automatically knows that C in and C out belongs to this std namespace. If you don't include this, in your program file, to be able to use C in and C out, you have to say, okay, you have to say std C out A. Okay, so that means that I am specifically telling the compiler that the cout is a definition inside this namespace. Okay, because I didn't say this at the beginning of the file. The compiler would not know where the cout is coming from. Okay, so as you might have guessed, you may have your own namespaces. Okay, you may define your own namespaces. For example, for a library, let's say we have a library that we wrote in Gebze Technical University, and all the classes, all the functions, everything that we define them under this namespace, GTU namespace. Okay, if you like, we can write our own cout object. Okay, I can say this. Instead of using std cout, I can say I am going to use GTU cout. I don't know what the difference would be. Maybe this cout prints everything to the screen, but before printing them to the screen, maybe it takes a backup of it. Maybe it sends all that information through the network to some server, and etc. So I can modify those definitions. So I can write my own namespaces. For now, this line will be kind of standard at the beginning of our programs. We say that I am going to use the names from this namespace std. Okay, this will make everything available. Yes.
So what's the difference between library and namespace?
Libraries are smaller. Namespaces include libraries. Okay. I mean, string is a library. It is inside std. Okay, vector is another library. It is inside the std again. So namespaces are larger than libraries.
Thank you.
Sure. Any other question? Yes.
So is it the same thing but more inclusive?
Did we?
As libraries, I mean namespaces. Just more inclusive. I mean, it's just bigger.
Yeah, I mean, in C++, you will not see the name of library anywhere. Libraries are definition. Okay, namespace and include are C++ keywords. So C++ language itself doesn't bother with what is a library, what is not a library. Okay, and I and the book, we use the library in a very loose sense. Okay, if code is written before and it is available for me to use it, I would call it library. Okay, so if you are talking about the precise decision of libraries, I mean, would you call a single book a library? A single book a library? Yeah, I would call it. It's a very poor library, but it's a library, right? Or 2 books or 3 books or billions of books. It's still a library. I mean, many people say that I have a library at home. How many books you have? I have 2. I mean, it could happen. So we are using the library in this sense. The definition of library doesn't come from the C++ language itself. It's a definition that we do between ourselves. By the way, if you don't want to make everything available from the standard namespace, okay, you will say that I am going to use only cin from this standard namespace. Okay, I am going to use just cout from this standard namespace. After this line, again, this cout statement works. Cout A works. Again, just for now, we are going to write this at the beginning of our programs. And when the time comes, we are going to look at the namespaces in a more detailed way. And we will write our own namespaces. And in fact, after that point, I will ask you always write your homeworks using in your namespaces and use them from your namespaces. And I think in midterm or in final exam, you'll have these kind of requests from me. Okay, use your own namespaces. Good. It looks like. Okay, I have 2 more minutes. Then that's the end of the chapter number 1. We didn't say much, especially I didn't say much about the object-oriented programming. maybe the only thing that I said about object-oriented programming is this string class is a nice example of object-oriented programming. Okay, why? I just make objects of this class. Maybe it is time for you to know about this. This is the object of this class. Well, in C we said that this is the variable of this type, right? In C++ we would do the same thing, but usually object-oriented people would say this is the object of this class, object of this class. So these are the classes, these are their objects. Okay, there is only one string class, but there could be many objects of string class, right? Like this, dog name, comma, A2, A3, D1, etc. So I have 1, 2, 3, 4 objects of this class string now. Okay, so it's like a variable name. Nothing has changed. We are variable declaration, but in C++ or in object-oriented world, we call them objects, and these are the classes. Yes? You had a question?
Yeah. Are they variables or objects?
What are the variables or objects?
So we can say there is no such thing as a variable in C++.
No, I didn't say that. But for the fundamental types, we still call these types for the fundamental types, and these are the variables. But the other types, the types that we have created, these are the classes, and these are the objects. Okay, it is our task to write new classes. Okay, and while we are writing our new classes, we use the objects of other classes within our classes. Okay, so what is our design philosophy of these classes? Write classes in a way that they are easy to use, easy to understand. Okay, this is very easy to use. I just declared it, and I use the stream extraction operator to get a name from the keyboard, and I use the stream insertion operator to print it to the screen, right? And if I wanted to, I could have said, okay, I could have said dog name plus assignment, and at the end I am going to put a dog in it. Easy to write, easy to understand, easy to remember, right? So we will write our classes this way, and we will never let our customers, our users of our classes, we will never let them know what is going on inside my class. Okay, I don't know how this string holds the characters. Do they use a character array or regular array or something else? I don't know, and I don't have to know. Okay, as a customer. So we are going to hide that information all the time, because knowing that information doesn't make my customer's job easier. Okay, knowing the details doesn't make me a better programmer. It's like knowing how the car works doesn't make you a much better driver, right? I mean, better driver means that you are always alert, you always watch the other traffic, and you have just two pedals. One accelerates the car, the other one slows the car. That's it. This is what you need to know, okay? Once you know this, once you don't stop thinking about how the car works, your job becomes easier, and you could be much more productive. What do I mean by this? While I am driving my car, I can listen to the news on the radio, right? So that's much more useful time for me. So I can know what's going on in the world. So something like this. I mean, knowing what's going inside the string will not make you a better programmer most of the time. So stop worrying about it. Just use it. Okay. as C programmers, yeah, this is kind of not intuitive. We think that we should know what's going on with our compilers and everything. Yeah, that's true. But in object-oriented world, even object-oriented world, we usually don't think about it. Okay, these are the theories, of course. And unfortunately, we will see some cases that this is what's going on with this object, and to be more efficient, don't do it. Remember what I said? I said use this instead of this, right? I said that. Why? Because I told you what's going on inside. Usually, other types of programmers, other than the C programmers, they don't care about these kind of details. They are not important for them because our computers are fast enough. Why should I worry about 100% speed up if 500% slow down is not important for me? Okay, I used too much time. Sorry. Let's take 15 minutes of break. Let's be here around 10:35. 35.
Is it okay to use our notebook to take notes in the class?
Why not? What do you mean?
I don't know.
Sure. Well, I had this question the first time. Right? You mean by regular notebook?
I saw nobody has opened the
Well, that surprises me too. Well, okay. Thank you for asking. But
Teacher, I'm not at the list.
niye İngilizce konuşuyorsun? Tamam.
Bilmiyorum, siz konuşuyorsunuz
Beni o
diye
İngilizce
ben
sordu.
şey sandım,
Ben de ne
herhalde
sordu
dedim
biliyor musun?
acaba hoca mı yabancı diye düşündüm ben de.
Ben de sizi yabancı sanıyorum. Kimse soru sormuyor.
Hocam ben listede yokum. Ben yüksek lisans öğrencisiyim. Bilimsel hazırlık sınıfı için gelmiştim. Bir de dersi online da alabiliyormuşuz galiba hocam. Teams'e eklenmem gerekiyor.
Sen hiç haberin yok mu dersten?
Vallahi yok hocam. Geçen hafta ben
Videoları
biraz
izle.
hastaydım.
Oo, ben yaraladım kitabı.
Tamam hocam, ben hemen izlerim.
İyi de ders herkes almıyor ki, ben randevuyla alıyorum dersi.
Öyle mi? Bilmiyordum hocam.
Randevu alıyorsun derse gelmek için. Videoları izle. YouTube'a koydum onları. Dersin linki var bölümün sayfasında. Gir orada.
Tamam.
3-4 dersi yükledim ben YouTube'a.
Tamam.
Sınıf 160 kişi olduğu için randevuyla alıyorum dersi. 40'ar alıyorum.
Tamam hocam.
Dersin silabusunu da oku.
Tamam.
Kendine bir iki arkadaş bul. Onlardan öğren yani, çünkü arkadaşsız falan. Danışmanın kim?
Unuttum hocam.
Erkan hocam.
Yok, Erkan Hoca değildi hocam.
Ne çalışıyorsun?
Ben makine öğrenmesi çalışacağım hocam.
Yakup Hoca.
Yok, Yakup
Erhan
da
Hoca.
değil. Bayan bir öğretmen.
Burcu Hoca.
Burcu Hoca galiba.
Tamam. Ya birileriyle konuş, özellikle diğer bilimsel hazırlık. Arkadaşlar ya, sınıfı çıkalım olur mu? Ders arasında havalansın buralar.
Hocam merhaba.
O çocuk ne sordu biliyor musun? Derste not alabilir mi hocam diyor. Niye soruyorsun? Kimse not almıyordu diyor.
Peki.
İlk defa yani bunlar, ben bilmiyorum, bunlar online gençlik. Bunlar nasıl şeyler ya?
Hocam ben de çok zorlanıyorum. Hocam ben endüstri mühendisliği bir yandan okuyorum. Şimdi hocam benim...
Bir dakika, sen yandan yaptıysan C dersi...
Yok, hiç yok bende hocam.
Niye aldın ki bunu o zaman?
Ama hocam ben bilmiyorum ki.
İyi de C'yi alman lazım yandan öğrencilerin ilk önce.
Hocam ilk önce müfredatta bu ders var.
Müfredatta bu ders yok. Sen bu dönem başladığın için böyle oluyor. C'yi almadan bunu alma sen ya. Sen git hocanla konuş, hocam ben miyim senin? Danışmanına. Seni bunu düşürüp sana şeyi yazalım. C dersi bu dönem veriyor. Gökhan Hoca veriyor. Sen onu al. C'yi almadan bu dersin hiçbir manası yok.
O dersin ne zaman olduğu ile ilgili sormadım. Yani bu... Evde olunca alışkınım tabii. Her zaman ne yapayım? Şunu çok fazla şey istiyorum. Kendimi çok alıştırmışım ya.
Bir programı çok hayatımda bir şey yapma var ya, o madde.
Doğru. O kadar yapmak Okay, any questions? Let me start chapter number 2, which is about flow of control, and I will be much quicker with this chapter because almost all the things are the same as CE. So let me clear out these markings. Okay, so only the new things about C++ I will talk. The others I will skip very quickly. In this chapter, I mean, you know everything about this branching mechanisms, if else, switch, nesting, if else, etc. And did I do the right thing? Why? Because I talked about, yeah, okay, it is here. Good, okay. And loops are the same, branching is the same, and there are small differences and new additions to C++ when it comes to the Boolean expressions. And at the end of this chapter, we will make a small introduction to file input-output, and that file input-output will be used in your second homework, I guess. Okay, before object-oriented programming, the popular ways of programming was the structured programming. And let's look at the structured programming principles, some of them actually. Object-oriented programming is not against structured programming. We should always follow the structured programming principles too. I mean, object-oriented programming is on top of structured programming. Structured programming says this: you write your programs either by putting statements one after the other. Okay, so this is a sequence structure. One statement, let's say a declaration, an integer declaration, an integer assignment, integer printout. Okay, so when you do this, this becomes a box. Now I have a new box like that, and this can be considered as a building structure. So I can take this statement and put it inside this box, another one and another one. Okay, so you can stack your statements one after the other like this. It is okay with this structured programming. Okay, so that's one way of putting statements together. Put them together and it becomes a box, and I can use this box anywhere I like. The second structure is the condition. With the condition, you put the condition here, if-else statements, for example. If the condition is yes, then I execute this part. If the condition is no, then I execute this part. Again, this part could be a very large box, very large box. This is the second way of doing things, okay? And the third way, okay, I can represent the second way either this way or that way, it doesn't matter. And I can do the third way is the loops, okay? I have a condition here and my statement, either there or there. This statement again might include other statements. By the way, this becomes another green box, okay? So I can put this green box in here, or I can put this green box in there, right? And this becomes another green box, okay? So you can form your boxes in either one of these ways: condition statement, loop statement, or the stacking the statements one after other. And this is called structured programming. Okay. The nice thing about the structured programming is that whenever you look at your, let's say this is your program, and there are boxes in it, okay, like that. If I take a look in this box, it will be either this way or that way or that way. There is no other way of doing things. The nice thing is, I can take this box from here, or take this box from here, take it out, okay, put, it doesn't like, okay, I can take this box from here, put it out, and put another box in there without affecting much of the program flow. That's why they have eliminated the goto statements in structured programming languages. Did they talk about goto statements in C language for you?
Yes.
I mean, maybe they talk about it, but they told you that never use gotos, right? Never use gotos. Gotos are, for a reason, it is forbidden. Why? Because goto says that you should go to from here to there. So it is drawing these kind of irregular arrows between these boxes. And if I do this, I cannot eliminate this box anymore, because this box and this box is dependent to each other. And if I keep doing this like that, okay, all the structuredness of the program goes away, right? We don't like this. We don't like this, okay? So in structured programming, we don't like gotos. In structured programming, what we do is, okay, stacking statements like this, or using the conditional, or using the loop structure. That's it. Nothing else. And there is a theory, it is proven that any programs can be written using these three combination techniques or structuring techniques without using any gotos. Okay. So why do you think that the goto is available for C then, if the goto is bad? Yes.
It was actually a low-level feature, but
Sometimes when you write but when you write it low level, that doesn't mean that you shouldn't write it in a structured way. I mean, low-level programming can be done and should be done in structured way. Low-level programming should be done using object-oriented way. Okay, if you are a human and you are writing C programs, don't use goto. What do I mean by if you are a human? C programs are not written by only humans. Okay, sometimes our software tools produce C programs too, right? I mean, for example, the first generation of C++ compilers, they used to produce C code. C++ compiler produces the C code, and you take this C code and compile it with a C compiler. I mean, while you are producing the C code, it is okay to use gotos in that C code, okay? So goto is available. C is a flexible language. They made it available, but for structured programming, never use gotos. And of course, for object-oriented programming, don't use gotos. Yes?
For the C, goto is like branching in machine.
Yeah.
For that we use C in goto. We use goto in C. More useful way in C++.
The goto statement in C is the same as branching in assembly language. And you are saying that branching is available in assembly. Why don't we use it?
Yes.
Well, usually, of course, when you take this statement, for example, a loop statement, okay, compile it, and you see that there are many branching statements inside the assembly, corresponding assembly of this one. Of course, in assembly, you have to use the branching, otherwise there is no flow of control. In that sense, if you are using in a very, very controlled way, if you are using the goto in a very, very controlled way, you are using goto only for this kind of stuff. Well, it might be okay, but don't do that. Don't take this risk, because you don't have to. You have the if structures, you have the while loop, you have the for loop, right? don't use gotos at all. I mean, you are saying that I trust myself. When I use the goto, I don't break any structured programming rules. That might be okay, but why are you using it then? I mean, there is a while statement and for statement. I mean, you may trust yourself, but other people are going to read your code. They may not be good enough to modify your code. Okay. Any other questions? So, flow of control of C statements are developed for this purpose, to do structured programming. As object-oriented programmers, we are going to follow these rules too. Okay. Write code in a way that your boxes can be easily movable around. Okay. So I can take this box and replace it with something else. That's why we don't like global variables either. Right? We don't like global variables, because if this box modifies a global variable, and if I remove this box from here and replace it with something else, then that modification of global variable will be in a very sad situation. So we don't like the global variables. So all the code should be local. Okay, their side effects should be very clearly defined. And if you are using functions, and your functions should take parameters well defined and should return values and etc. So you are going to talk about this more when you take this programming languages course. Okay, let's look at these. Remember the outline of this chapter, expressions. Okay, let's look at this. Let's look at from this Boolean expressions. As I said before, there is a new type in C++ named Boolean. This one can take either f is false. F is another good name. Let me make it B1, Boolean 1. Either false or B1 could be true. So false and true are two C++ keywords. Bool is another C++ keyword. Okay, and with this type of variables, Boolean variables, these are the type of operators that you can use. Okay. This one will return either true or false. This one will return either true or false. It is not like C. In C, this one will return 0 or non-zero, right? In C, all of them returns 0 or non-zero. In C++, okay, it will return true or false. There is a separate type in C++ for Booleans. So true, the 0 or non-zero still works for C++, but we don't prefer it. Okay, we don't prefer it. We don't. In C++, they write statements like integer a5 while a do something and decrement a by 1, right? This is an acceptable code in C. True? Yeah, we don't like this in C++. So how would you change it? I would change it like while a is not 0, do this. Right? So this will return a true or false statement value, and while would work that way. Okay? So logical statements are like this. So all of them would return. These are the logical operators. They will all return true or false, and they are all available. Okay, new type bool. It's a new, and values are true or false, and these are the language constants. We talked about them. And this operator, these operators, logical and logical or operators. These are logicals. Okay. What is logic? Can anybody give me the definition of logic? Mantık in Turkish. Logic. It comes from the Greeks 2,000-3,000 years ago. They say they are teaching me like that. They are teaching us it like that. So what is the definition of logic? Logic is actually any formal way of making inference from what you know. Çıkarım yapmak. Okay? Making inference from what you know. So, especially with the propositional logic, önermeler mantığı, rules are very simple. You know things, and from the things that you know, you make new inferences. You come up with new truth. Okay? And logic comes from that, and we are using only a very small part of this idea of logic. We say that things are true or false. If I make operation on these observations, what I can do is, one of them is logical OR, the other one is logical AND, and these are the truth tables of it. Okay, if I have an expression, like this, expression and expression, if both sides are true, then the result of this one is true. You already know this from C, and we are not saying anything new. Only what we are saying is that the result of these statements are true or false, not zero or not non-zero. The other thing is that these two operators, they operate in a short circuit way. You short circuit, kısa devre, short circuit. So what do I mean by this? Okay, it's like this. When I say if A, B, or C equals D. Okay, there is an OR statement here. This is short-circuited. The compiler, in this case, let's look at the expression tree, or equality A, B, equality C, D. Okay, so the the compiler, in this case, remember yesterday what I said? I said we don't know if this one is going to be evaluated first or that one, right? In this case, the compiler knows it. Compiler definitely evaluates this one first, and if this one is true, it doesn't evaluate the second part because it knows the result, right? If this is true, it doesn't evaluate the second part. If it is false, then it evaluates the second part. Result is the second part. So this is called short circuit evaluation, and it is done both for logical AND and logical OR operations. Of course, for the logical AND, it evaluates. Let me do this with the logical AND. Okay, if this is, it evaluates this one. If it is false, it doesn't evaluate the second part because it knows that result is going to be false. So why am I telling you this? Why is this important to know? I mean, I'm telling you, I spent like 5 minutes to tell you what we are doing here. Why is it important to know? Why is this important to know that sometimes this part is not evaluated for AND and OR? Yes? Yes. You talk too much, yeah.
For efficiency reasons.
Yeah, for efficiency, yeah, that's true. It is nice to know the efficiency, but this is much more than efficiency. This is about program correctness. Even without the efficiency, this is about program correctness. Sometimes the second part is not evaluated. Well, I mean, the result is the same, right? Result won't change because instead of comparing these two, I will not compare it. And I know that the if statement is going to behave exactly the same. But how about this? How about this? If somebody writes a program, crazy program like this, okay? So do you see it? It evaluates the first part for OR. If it is true, it doesn't evaluate the second part. So that increment operator will not get evaluated, right? So your if statement is a weird if statement. It sometimes increments C, sometimes it doesn't increment C, right? And this is not a good way of programming things. Don't do this, and be aware of it. For other operators, for example, Instead of this or, let's say I have some comparison operator and etc. In that case, both of the size will be evaluated. The result will not be that different, but in this case, again, you should be careful about this. So don't do this. This is a bad way of doing things, and you should know why it is bad. Okay? Good? Small details, but important details. Okay. Good. Let me move on. Okay, here is our precedence of the operators. It doesn't give me the associativity, but it is a precedence. Okay. So at the top of the precedence, we have the scope resolution operator. Remember this? Two columns, std column, cout. That's called scope resolution operator. You are saying that the scope of the cout is within this std namespace, etc. And we are going to see it a lot with different cases. And after that, okay, so this is the highest. Next level is these operators. Dot operator. So what is dot operator? Remember, if this is my string, blue. If this is my string, when you say length, okay, this is the dot operator. So you are accessing the member of a struct, function member in this case. Or the arrow operator. Remember the arrow operator? What did we use this operator for? Yes?
Pointers.
With the pointers and structs, right? Pointers and structs. You are saying that I have a pointer of a struct object. I am going to access this member of it. Array indexing, again, a very high priority. Function call. This is not 2, 3 plus 1 is not a function call operator, but this one is a function call operator. Okay. Question for you. How many parameters does this indexing operator take? Question, easy question maybe. How many parameters does this plus take? Just two, it's a binary operator, right? How many parameters does this indexing operator take? Okay, two is a better answer. Well, in C++ there are only two answers for this one, just one or two. Well, there is another operator that takes 3 parameters. Do you know what that operator is? An operator that takes 3 parameters? Ternary condition operator, and we are going to see it. So this index operator takes 2 parameters. Here is 1, here is 2, right? 2 parameters. So this one takes 2 parameters, 2 parameters, 2 parameters. How many parameters does the function call take? We don't know. It can take 1, 2, 3, 4, 5, depends on the number of parameters. So this is a very unique operator. It can take as many as it wants. How about these? This one and this one. Just one. These are unit operators. But by the way, this is a postfix. It's not prefix. Okay? This is prefix. This is postfix. Postfix has higher precedence than the prefix. Okay? So this is the second level, and I have the third level of precedence. Okay? Look at this one, typecast, C typecast. Okay? This typecast is different than function call, and it has a lower priority. And all of these unary stuff, this one is a unary minus. This is not A minus B, but minus B, right? Unary minus, unary plus, dereference. This is not multiplication. This is dereference, pointer dereference, address of operator. These are new, delete, and we are going to see them. These are new operators for C++. Size of we already know. And this is the logical NOT, right? This is the logical NOT. Okay, good. These are our operators, and then we have the regular arithmetic operators, multiplication, division, modulo, etc. Then addition, subtraction. These are all binary. And stream insertion, extraction operators here, or left shift, right shift operators. These are overloaded. And then our logical operators, less than, greater than. These all will return. These all will return true or false. And it's a nice thing. It's a nice thing that these all have lower precedence than the others. For example, I mean, equal is equal, not equal. I could write things like what? Battery. Okay. I could write things like A plus B is equal to C plus D. I can write this without any parentheses. Why? Because these two have higher precedence than the is equal to operator, right? Equal to operator. So they designed it that way. Or I could write things like A plus B is equal to D plus C, or A is not equal to C. I don't have to use parentheses here because or and has a higher precedence than comparison operators or the binary operators. Okay, so there is a logic in designing this kind of table, the precedence table. Okay, we read it that way. So they are designed in a way that we don't have to use parentheses all over. Okay, and at the end, as expected, we have the assignment statements. How about this? What do you think the type of this A is? What is the type of A? What? Boolean, yes, it's a Boolean. And I write it right. Okay, this is correct. Why? Because the assignment has a lower precedence than the smaller than operator. This will produce a Boolean and I will assign to A. And this will work. Here is our conditional operator. This is a ternary conditional operator. It will take 3 parameters. Why? Because I write things like this, right? A less than B. Okay. 3, 4. When I say things like if, okay, let me do it this way then. True and false. Parameter number 1, parameter number 2, and parameter number 3. So this ternary condition operator takes 3 parameters. Of course, you should never use this operator. With this kind of usage. This is purely confusing. Why am I doing this? I mean, why don't you say A less than B? But I'm giving you just an example. So this is usually very useful if your if statement is very simple. Instead of writing 3 lines of if statement, if this is then this or else that, I would use this one. I mean, you could say, for example, if if A is less than B, call function 1, otherwise call function 2. This is kind of okay, but writing this kind of ternary condition operator makes it confusing. Don't write any confusing code, okay? The code that you are writing should be easily understandable by everybody. Okay, this is bad code, this is good code. Okay, we didn't talk about this throw, and we are going to talk at the end of the semester. As you see, I keep telling you at the end of the semester will be very busy, and so you will be busy learning new stuff and doing homeworks and etc. So beginning of the semester is very important for you, very critical for you. Okay, try to stay ahead. Okay, before coming to class, read the chapter and come with the questions. Ask me lots of questions. And finally, we have this operator, comma operator. Okay, comma operator has a very low precedence. Okay, and we use comma operators. Where did we use the comma operator? We keep using comma operator. When you learn C, you use the comma operator a lot in some position. Yes.
Array initialization and function calls.
No, function calls, it is not comma operator. For the function calls, those commas are the syntax of the function call operator. Okay, that comma operator is different. Yes.
Class. In class.
Class.
Yeah.
In C you don't have class. What do you mean?
No, in CBP.
I'm talking about C.
Oh, okay, sir.
Last semester you used the comma operator a lot. It's an operator. What's an operator? Takes some parameters. This comma operator takes 2 parameters and returns a value, like the plus operator. And we use this a lot. We use this comma operator here. For I is 0, J is 1, K is 3, K less than 5, plus I. In this statement, these are the comma operators. Okay. What does the comma operator do? Comma operator takes 2 parameters, it evaluates them, and returns the rightmost one's result. Okay. So, and it guarantees that it is going to evaluate the left side first. So this one will be evaluated first, and then this one, and then this one. Okay, this is how the comma operator works. So it is one of the special operators. Why? Because it tells you which side it is going to evaluate first. Other than the comma operator and the logical OR and AND operators in C++, we don't have any other operators that tells you which side it is going to evaluate first. Plus operator doesn't tell you that I am going to evaluate this first word or the next one, left or right. Okay. Comma operator but tells you that, okay, it says that I am going to evaluate this one, then this one, then this one. And it has a very low precedence. Why? Because before the comma comes in, it needs to evaluate everything before it. Okay, that's the comma operator. Good. So how would I draw the expression tree for the statement then? Let's look at this one. So this is a by the way, oh okay, maybe I made a small mistake. This is a for loop. I just write F. No. This one. For loop. Okay, so for has 3 parameters. Okay, here is K and 5. Here is plus I, and here what am I going to do? Let me do it like that. There is a comma, and it goes that way, 2 parameters. Okay, you tell me. Of course. What should I write here or there? Okay. Okay, here is a comma or something else. Here is an assignment statement. This is I and 0. Here is a comma and 2 assignment statements. What? J1 and K3. I am sorry, I squished everything, but let me try to fix it. Okay, good. Try to write the same thing again here. This is K, this is 3, 1, okay. So comma says that definitely this comma says that I will do this first. Okay, then I will do this comma. But this comma says that I will do this first, then this one next. Okay. Good. Any questions about this presence table? Again, this one doesn't talk about the associativity, but for all the operators, associativity is from left to right, other than the assignment statements. For the assignment, it is right to left. Okay, and you know why we are doing right to left, right? I mean, if I do A gets the value of B gets the value of 2, okay, making this assignment doesn't make any sense first, because what does this return? It will return the value of B, so this one will return a value, and I'm trying to assign a value to another value that will produce a compiler error. So it is right left. So do this first, it will return 2, and I will assign it to A. Okay, there are some precedence examples. Okay, this means, this one means this, but I don't have to parenthesize anything, because I know that out of these, okay, this one and this one has higher precedence than the others, so they will be done first. But I don't know which one is going to, no, I know actually. Okay, this is tricky, right? This plus is going to be done before than this plus, right? Why? Because there is an OR statement here, right? So this side will be evaluated first, than that one. Short circuit evaluation, I already talked about it. Be very careful about the short circuit evaluation. I mean, knowing that is a performance trick is a good thing, but with the performance there is a problem, like this one. This y will be incremented sometimes, will not be incremented other times, depending on the value of x. If x is not greater than 1, then y will be incremented. If the result is not 0, this one will return true. Very tricky statement. Don't write these kind of statements in C++ or C. It is very difficult to understand these kind of stuff. I mean, you will confuse yourself too. You are going to write it and it will work for a while. Compiler will compile it and run it. But later when you come back and read it, you won't understand what you meant. Okay, good. Any questions? You are too quiet. Ask me questions. Where is my attendance sheet? What happened here? Okay, it is empty. If you don't ask me questions, I will pick somebody and make you ask question. Anybody? No. Okay, Barış Özcan, where are you, Barış? Barış, ask me a question. I don't have a question is not a question. I don't have a question is not a question. I am making jokes, nobody is laughing.
We can actually use C original, classic C libraries in C++, right? std library.
Yes. Yeah, okay.
And I don't know, I'm asking because, for example, if I want to use printf command in C++.
Well, yeah, if you have to, you could, especially if you have an old library which you like in C and you like to use the same library in C++, and you have your code available, you do. But if you are writing fresh code for C++, don't use anything from C. Okay? I mean, you might say that I need this and this and that, okay? But if you need C library is that bad, then write your code in C then. By the way, to be able to write object-oriented programming code, you don't need to write them in C++. You can practice object-oriented programming principles in C or in assembly, actually, because there are only a few rules in object-oriented programming. Okay, one of them is information hiding. information hiding. Okay, hide all the information from your customers, okay, as much as possible. Don't let the customer know what you are doing inside your functions, inside your procedure, etc. And I can apply this principle in C and assembly. The second one is encapsulation. Encapsulation is putting everything together that is needed to use a library. That would include the data and the functions and etc. So we are going to see how we can do this in C++, but in C it is the same thing, okay? This is my data, and these are the functions of working on that data, and you are not allowed to come in and use this information. And I am going to manipulate that data. You are not allowed to modify it. That's called encapsulation. And we have inheritance. Inheritance is a code reuse example, and we are going to see examples of it later during the semester. But it is basically, if you have a very nice code, this is running very nicely, but you need to make a small modification to it to make it fit to your current needs. But the old code has to stay there because everybody is using it. It is nice already. For example, that string, right? String class is very nice, but I like to add a new function to it. For example, I don't know. For example, to upper. I need to add this function to upper. So I need to convert the lowercase letters to the uppercase letters to that string class. You don't have to you don't have to modify your string class. Okay, string class stays the same. You inherit all that functions from the string class, and you make your modification in your inheritance. Okay, I can apply all of these rules in assembly or in C or in Pascal or in Fortran. Okay, so object-oriented programming principles are like structured programming principles. Remember this? What did I say? You can apply these rules in assembly too. You don't need C. And it is the same thing. So back to your question. If you really need those libraries in C, then use C language and apply your object-oriented programming principles in C. And you will end up writing an object-oriented code that is maintainable, easy to understand, easy to modify code, right? But you will not get any help from the compiler. With the C++ or Java compiler, they will help us. Just like C compiler helps me writing this kind of condition statements or the loop statements, right? So C++ compiler or the Java compiler or C# compiler, they will help me write nice object-oriented programming code. Okay, they are just helpers. Just because I am using C++ compiler doesn't make me a object-oriented programmer. Okay, you have to observe the rules. You have to observe the rules of object-oriented programming. Okay, so that was a nice question. Thank you. I think I am out of time. Tomorrow I will continue with some of you maybe, and we will finish up this chapter number 2, and your homework is coming maybe tomorrow. Okay? So learn that game, solo test. I am not hearing you. I am not. Say it louder.
I don't really understand the difference between class and structures.
Well, they are very similar actually. I mean, in structures, you have only data. Okay, in classes, you have data plus functions. Okay? So we will, and that's called the encapsulation, putting everything together, data and functions. Tabii.
Ödevlerimizde 98 mi kullanalım yoksa 11'den bir şeyler kullanabilir miyiz?
11 kullanacaksın.
11 kullanacağız.
Ha, söyleyeceğim zaten.
Hocam ben attendance'ı dolduramamıştım da geç geldim.
Ne zaman geç geldin?
15 dakika falan geciktim.
İlk derste mi? Niye o zaman gelmedin ki?
Dersi bölmeyeyim diye.
Yok dersi bölme. Ders arasında niye gelmedin?
İnşallah. Kalem var mı?
Kalem var mı lan bu? Allah'ım yarabbim ya. Yok bende kalem var. Var da vermiyorum. Kalemsiz öğrenci türedi ya.